In this question, we're tossing a coin 5 times and we're looking for the number of possible sequences that have more than 3 heads, which means either have 4 heads or 5 heads. So we're going to solve each of these separately and then combine them to get our final answer. Now we start out having 4 heads and 5 positions or 5 tosses that those heads could be in. So we're going 5, 4, 3, 2, just like normal. And when we multiply that out, we're going to get 120 possible sequences. However, the order that the coins are in those positions doesn't make any difference. So what we need to do is divide by the number of choices we had, factorial or 4 factorial, and that's going to give us 5 options for getting 4 heads. Another way to attack this part of the problem is to treat it as a straight combinatorics question and use combinations and the formula. So we'd be looking at 5 choose 4, which is going to be equal to 5 factorial over 4 factorial times 5 minus 4 factorial. That's going to equal 5 times 4 times 3 times 2 times 1 in our numerator, and 4 times 3 times 2 times 1 times another 1 in our denominator. And we can cancel out the 4s, 3s, 2s, and 1s, and that's just going to leave us with 5 over 1, or the answer we got before, which was 5. Now to deal with the second half of the problem, we need to figure out how many ways 5 heads can be formed from tossing a coin 5 times. So we're going to have 5 heads that we're dealing with, and 5 positions that those heads can be in. So we could start out in the 5th, then the 4th, then the 3rd, then the 2nd, then the 1st. We multiply all of those, and again we get 120. But again, the order doesn't matter because we can't tell the coin tosses apart. So we need to divide the total that we got by the total number of heads that we had factorial, or 5 factorial, which is just going to give us 1. Now, we could also have treated this part as a straight combinatorics problem and used an equation. For 5 choose 5, we're using a combination because we know that the order doesn't matter, and that's going to be 5 factorial over 5 factorial times 5 minus 5 factorial. Now here we run into an interesting issue with factorials. We'll get 5 factorial over 5 factorial times 0 factorial. Well, 0 factorial is just equal to 1. So we just have 5 factorial over 5 factorial, which is 5 times 4 times 3 times 2 times 1 over itself, which is just going to divide out to 1. So now, to find the total for both 4 and 5, it's going to be the combination of 5 choose 4 plus 5 choose 5, which is going to give us 5 plus 1, which is going to give us 6, which is our final answer.